Hey friends, I'm Rohit Verma, final year student from Thapar Institute of Engineering and Technology, and this is the video representation for my project semester that began in January 2018 at Holidify.com. During my course there, I worked on full stack web development for features at Holidify, as well as I worked on data analysis to provide an enthralling experience to the users based on recommendations and previous searches. Holidify is a leading destination discovery platform in India with more than 4 million views per month on an average. It is also one of the best platforms with structured content that is available in India. Now coming on to the framework that Holidify follows, this is the Spring framework that is followed by Holidify. Spring framework is defined in three layers, that is the web layer of the controller layer which interacts with the front end, the service layer which acts as an interface between the repository layer as well as and the controller layer, and the third one is the repository layer which interacts with the database to fetch details and information about the data that is required by the user. So the repository layer sends the data to the service layer in the form of objects, and these objects are then sent on to the controller layer which are rendered by the front-end JSP applications. Now coming on to my very first project, that is the destination stay project, which involved working on with the booking.com API and fetching results from that API, converting the results into objects, and then rendering those objectual results in the front end. So this is how a destination stay page looks like. Rather, it's a complete destination, it's a complete stay page only made for the hotels. So let's search for Manali here. So as we can see that these results are fetched in real time from booking.com, and these prices are those prices which the booking.com also displays. Currently we don't have the facility to book hotels right here on the Holidify website only. So we redirect the person or the user to that hotel being on the top at booking.com website. The next project that I took up was designing the ATFs and modifying the search UI. So let's see how the older ATF looked. So this is the landing page for Goa at holidify.com. This was the earlier landing page at Holidify. So this was a rather static page with this overview widget on each and every page of the tabs that are shown here. So let's check out how the new page looked like. So yeah, this is the new revamp page of the Holidify landing page for Goa that I worked on. So this has a photos widget here which redirects the person to photos of the Goa page. We have added the rating feature for Goa as well as adding to the wishlist feature. Also, the links that are present here are those which were mostly clicked by the users when they visited any of the destination landing page. Consider places to visit or some other features that I mentioned here. Coming on to the search at Holidify was also improved using the new indexing and the new type feature that was included in the search results. Using the type feature, I added on the icons before the search results. So let's see what Dharamshala gives. So yeah, the Dharamshala provides with different types of results. The first one including the destination, second one including the places to visit, which is a list view. These are the special attractions in Dharamshala that one can visit here at Holidify. So this is the workflow of how the search works. So once the user types into the search box, the query is sent to the Solar server. Solar is basically a repository which indexes the search results and displays them when the user requests them. So the results are matched up using the query, and the data here is indexed so that the user gets quick response whether the results found or not. So if the results are found, then the results are accumulated in the defined data type for type ahead and then are sent to the front end to the bloodhounds. The bloodhounds are the suggestion engines which are used by the search at Holidify. The bloodhound will send the result to the type ahead which then adds icons using the attributes of type that is included in the search format. After the rendering these results, the results are displayed to the user below the search box. But in case the results are not found, an empty list is returned, and this is checked at the JS level of the front end, and it displays that no results are found. Let's see how the no results found work. So yeah, it got an empty list, so it displayed the no results found text. After searching, I worked on calculating the relevance score for featured posts on Holidify. So how it worked was the Python script fetched the GA, that is the Google Analytics data for the page views. This data was then segregated in CSV to get the page views content and the respective link. So the featured post data was fetched from the database, that is the data that was earlier showed at Holidify website. This data is converted into a dictionary to match with that of the page views data. The page views are then segregated by views per link, and the weights were added to the links as per their preference. That is, either the name of the URL is in the name of the post, or it's the current one name that is in the name of the post. After that, the average of those values are found, and the standard deviations of the values are found, and that data is used to get the standardized result from the whole list. That standardized number for each and every value is used as the relevance score for that data. This data is then updated into the database server, and the final outcome is displayed with the new relevance score. After completing the relevance score project, I shifted on to data analysis project. I worked on it along with other team members of mine. So since the data was collected using datacapture.log, I worked on writing a script which would read datacapture.log and clean out the results which contained the day prior to the current date. So since the data was captured on 22nd of May, so all this data belongs to the 21st May. Let's see. So yeah, the data belongs 21st May. That is the server timestamp here set is 21st May. So collecting all this data was then sent to the Amazon S3 server. So Amazon S3 server we need to create a bucket on Amazon S3 server and use the access key ID and the access secret key to access that bucket. Then we can simply upload this file to the Amazon S3 server. Let's see how it is done. So this is our S3 Manimet console here. We have created a bucket called HLDFY, and we can see that there are currently any files in the bucket. Let's upload a sample file into the bucket. We have a file named Hello World here. So let's upload this file to Amazon S3. The script runs, it uses the credentials here, and it uploaded the file name that we defined here. So yeah, file is uploaded to the Amazon S3 server. Now if we'll reload this page, it will show us a file stored here. So yeah, here we have hello.txt uploaded currently. So this was the last project that we are working on, and using this data at Amazon S3, Amazon also provides us the facility of using the data for analysis using Amazon Athena. Amazon Athena uses Hive framework to access the details of the data stored in the JSON format and apply SQL type queries on the data so that the data analysis becomes an easy task. So this was the last project that I worked upon at Holidify. I'd like to thank my mentor, Mr. Kovid Kapoor, as well as all the people associated with the project at Holidify for their continued support and motivation to me. Thank you a lot.